Let's practice these force problems. What is the force a car applies to a tree if the car has a mass of 2,590 kilograms and it is accelerating at a rate of 2.5 meters per second squared? So first step is to write down what we know. We know that the mass is 2,590 kilograms. And it has an acceleration of 2.5 meters per second squared. And we're asked to solve for force. This is a relatively simple one because we know that force equals mass times acceleration. So we can plug directly into our equation. We can see that our force is 6,475. And let's talk for a second about units. Nothing cancels out, so we get kilograms times meters per second squared. It's almost the units for momentum, except for momentum we're kilograms times meters per second without a squared. And this unit actually has a name. Instead of writing kilogram times meters per second squared, we can call it a Newton for Isaac Newton. So 6,475 newtons, and it is a capital N. Let's try a second example. If an object is falling with an acceleration of 9.8 meters per second squared and hits the ground with a force of 150 newtons, what is the mass of the object? So it tells us acceleration of with a force of, if you read your problems, a lot of times it tells you what these variables are. And what is the mass? So we know F equals ma, and we need to rearrange. We can use a magic triangle if we would like. F is ma. So to solve for mass, we have F over A. So we have 150 newtons divided by 9.8 meters per second squared. And you might look at those units and say, well, that's not going to cancel out. But remember that a newton is the same thing as this. So it's really like writing kilograms times meters per second squared, and those cancel out, giving us kilograms, which is what we should have with our mass. You don't have to write that out every time, but be aware of that if you look at it and go, that shouldn't cancel out. So you have a mass of about 15.3 kilograms. Let's look at another example. If a softball has a mass of 0.48 kilograms, and it hits the catcher's glove with a force of 23 newtons, what is the softball's acceleration? So if we look at our triangle up here, A equals F divided by M. And it's important to note that this F is capital, where most of our symbols have been lowercase. So 23 newtons. And remember, this is kilogram times meters per second squared, so we do get meters per second squared for our units. We have an acceleration of 47.9 meters per second squared. Try a few of the practice problems below and make sure you're getting the correct answer, and let me know if you have any questions.